AI can now write and ship code almost by itself. 90% of developers use it daily. Output is way up. But all that new code has to go somewhere. It's piling up faster than any human team can review. A new model is emerging, the Agentic Software Development Lifecycle. Humans now step in at just 3 checkpoints. Everything else runs on its own. Top subscribe because the way software gets built is quietly changing. For decades, every piece of software followed the same 6-step path: plan, design, code, test, review, and ship. A human sat at nearly every single stage, writing, checking, and approving each piece by hand. Then, AI coding assistants arrived, and one specific part of that entire chain sped up fast. 90% of developers now use AI daily, and most feel noticeably more productive because of it. The median developer now spends nearly 2 hours of every workday working directly with AI. Individual output has surged: 21% more tasks finished, 98% more code submitted. Yet trust remains split. 30% say they trust AI-generated code little or not at all. Researchers call this the Acceleration Whiplash: real gains at the top, hidden costs building underneath. One controlled study found developers believed AI sped them up by 20%, but were actually 19% slower. Developers now juggle 67% more open pull requests than they did just last year. Work restarts are climbing too, tasks bouncing backward after they were already marked as done. AI adoption also correlates with a measurable rise in software delivery instability across teams. More than a quarter of started tasks now stall for a full week with zero activity. So the real bottleneck was never writing code. It moved downstream into review and release. Humans became the traffic jam, drowning in a volume of work no single team could review. Some organizations report their overall shipping speed hasn't improved at all despite the AI boost. Not every organization benefits equally. Researchers identified 7 capabilities that determine whether AI truly helps. That gap between individual speed and organizational output is exactly what a new model targets. Engineers call it the Agentic Software Development Lifecycle, restructuring the entire process around autonomous execution. Instead of humans approving every step, they approve only a few critical checkpoints along the way. The rest of the pipeline, planning, coding, testing, runs largely on its own, in the background. Picture the agentic loop not as one assistant, but 3 separate agents working in sequence. Each loop triggers automatically the moment a new signal arrives, with no prompt required. Older copilots wait for a human to type out a request before doing anything. Agentic loops work the opposite way. They act first, then simply present the finished result. Underneath every loop sits a control plane, keeping each agent's actions on a leash. Loop 1 begins with a planning agent that never actually sleeps. It constantly scans production telemetry, user complaints, and backlog tickets around the clock. Within minutes, it can draft a full feature spec without a single engineer involved yet. A human still reviews that draft at the very first checkpoint before anything moves forward. Before touching any code, the developer agent pulls from an organizational knowledge layer of prior work. Loop 2 hands that approved spec straight to a developer agent inside an isolated sandbox. It writes a failing test first before writing a single line of real code. Then it writes just enough code to make that failing test finally pass. If the test still fails, the agent rewrites its own code and tries again alone. This red, green, repeat cycle can run hundreds of times before a human ever sees it. Loop 3 is where a separate agent turns deliberately hostile on purpose. It fuzzes the finished code with broken inputs, hunting for crashes and security holes. This adversarial agent checks for vulnerabilities that no developer thought to test for. Every flaw it finds gets patched automatically before any human ever sees the flaw. By the time a pull request reaches a human, it has already been tested 3 times. Every action any agent takes gets logged with a verifiable identity and a replayable audit trail. Checkpoint 2 isn't a code review anymore. It's a final judgment call on whether the system got it right. This isn't one company's marketing pitch. 3 unrelated startups landed on the same solution independently. One company began as a simple developer portal, a dashboard tracking who built what. That company, Port, raised $100 million once it rebuilt itself around autonomous engineering agents. Its platform now runs inside GitHub, Visa, and PwC, governing agents at enterprise scale. Port began 3 years earlier, raising its first funding round before agents were even part of the plan. A second company took a completely different starting point and arrived at nearly the same place. That company, Augment Cosmos, built a cloud platform where agents share memory and context across a code base. It earned formal certification for how it governs data, identity, and automated decision-making. That control plane keeps every agent's memory synchronized so no agent overwrites another's work. A third startup started even smaller, 4 people building agents for banks and hospitals. StackAI separated every agent into development, staging, and production, just like traditional software teams. It also holds certifications covering healthcare, finance, and government data, standards banks already trust. Nothing reaches real users until a human admin approves the change first, every time. That governance model made StackAI valuable enough for a major workplace platform to acquire it outright. 0 coordination, 3 companies, 3 founding stories, yet all 3 built the exact same checkpoint model. That kind of convergence rarely happens by accident in a fast-moving, competitive industry. Analysts at Gartner project this model could raise software delivery speed by 25 to 30%. It usually means the underlying problem is real and the solution space is genuinely narrow. Every one of these platforms is now used by real engineering teams in production. Not a research paper, not a demo. Actual companies running actual agents on actual code. The question now isn't whether this works, it's how far it can scale. Gartner tracked this shift closely, and their numbers show just how fast it's moving. Right now, only about 5% of platform engineering teams use AI across every phase. By 2027, Gartner projects that number climbing all the way up to 40%. That's an 8-fold jump in adoption in under 2 years, industry-wide. But scaling this fast comes with real growing pains that engineering leaders are already reporting. One agent can now generate 40 separate pull requests in a single afternoon alone. Human reviewers are drowning in code they never personally wrote line by line. Engineers call this review saturation, and it's already showing up across the industry. Unchecked agents also tend to duplicate work, quietly bloating a code base over time. Researchers now call that slow decay architectural drift, and it's genuinely hard to reverse. One wrong assumption from an early agent can cascade into failures several steps downstream. A single hallucinated internal function can quietly break an entire feature downstream. So the checkpoint model isn't optional polish, it's the only thing preventing real chaos. Now here's the encouraging part. Teams that implement checkpoints properly see real results. Gartner's own projection is direct: 25 to 30% productivity gains by 2028. That's not individual output. That's the whole organization shipping measurably faster than before. Port's own enterprise customers report faster incident resolution once agents handle routine triage. The difference between chaos and results almost always comes down to one single factor. Teams with strong governance and clear context layers pull ahead of teams without them. Teams that skip that step tend to drown in exactly the chaos described earlier. So the data tells a split story: massive potential paired with a real execution gap. Which side of that gap a company lands on is rarely left to chance. It comes down to deliberate choices about governance, context, and where humans stay involved. Those choices are exactly what separates a company riding this wave from one drowning in it. Every agent now needs something that never existed for software before: a verifiable identity. Every commit, every pull request now needs a traceable owner behind it, human or machine. Engineers borrowed identity standards built for humans and stretched them to cover machines too, but there's still no single unified framework every company agrees to follow yet. Every company is currently building its own version of the same governance rulebook. Web browsers went through nearly identical chaos before the internet finally settled on shared encryption standards. That patchwork approach works for now, but it won't scale cleanly forever across the industry. That gap opens a harder question nobody in the industry has fully answered yet. When a cascading agent failure causes real damage, who is actually responsible for it? Remember, one wrong assumption early on can quietly break several features downstream. Is that the fault of the company deploying the agent or the platform itself? Right now, most contracts simply haven't caught up with that exact question yet. Some insurers have started drafting new liability policies specifically written to cover agent-related failures. Checkpoints help, but they don't fully resolve who owns the outcome of a failure. That uncertainty is a genuine open problem, not a detail anyone has quietly solved. There's a second, more human consequence tied directly to which coding tasks agents absorb first. Agents are especially good at exactly the simple, repetitive work junior developers used to learn on. That's traditionally how new engineers built real skill, one small task at a time. Some engineering leaders now worry openly about where that training pipeline goes from here. If agents handle the easy work, where do new engineers actually build their skill? Others argue the entry point simply shifts, not disappears, toward reviewing and directing agents. Some universities have already begun adding agent oversight and prompt design to their curriculum. Both views currently exist side by side, and neither one has clearly won yet. What's clear is that none of these three questions have tidy, settled answers yet. Identity governance, accountability, and the junior pipeline are all still actively being written. That's not a flaw unique to this technology. Most major shifts start exactly this messy. Cloud computing faced this same trust gap 15 years ago before it became the default. The checkpoint model at least gives humans a real say in how this unfolds. That's a meaningfully different position than simply letting the technology decide on its own. None of these open questions are reasons to slow down. They're reasons to stay deliberate. Whether these open questions get answered well may shape the entire next decade of software, and that decade is already being written right now, one checkpoint at a time.
So AI didn't make software slower. It just moved the real bottleneck somewhere else entirely. 3 companies working completely alone all found their way to the exact same answer. Humans stepping back from every line, but staying firmly in charge of every decision. That balance is exactly what makes this shift feel different from pure automation hype. Right now, some code is shipping without ever passing through human hands. Software isn't just being written faster now, it's being built differently. Hit like, share this with someone, and subscribe to SynthCosmos. We cover the science reshaping our world as we know it every single week. We'll see you in the next one.